Nestled between the Bitterroot and Sapphire Mountains lies the small community of Hamilton, Montana, a quiet little town with world-class importance. Here sits Rocky Mountain Laboratories, a leading National Institute of Allergy and Infectious Diseases research facility that has shaped the understanding of infectious diseases for more than a century. What began as a local response to a deadly mystery quickly grew into a laboratory whose impact reaches far beyond Montana and into the world. The story didn't stop with its early scientific breakthroughs. Today, Rocky Mountain Laboratories is still buzzing with discoveries of all sorts, especially when it comes to something Montanans know all too well: tick-borne diseases.
You can trace back the origins of Rocky Mountain Labs to right around the turn of the 20th century, when a new infectious disease emerged, a new disease emerged in western Montana in the Bitterroot Valley in the mountains on the west side. And the people who got it were mostly people who worked in the woods, almost exclusively people who worked in the woods. It was a very severe illness. It was characterized by high fevers, really, really bad headaches and rashes. A fair number of the people that got it died. People didn't know what caused it, they didn't know how to prevent it, and they didn't know how to treat it. So the history of what became Rocky Mountain Labs initially started out as trying to understand what this disease was, and it was called a number of things, including black measles and spotted fever, and it ultimately came to be known as Rocky Mountain spotted fever. And the scientist who figured it out, there were some people who had some early ideas, but the person who came up with the definitive answer was an infectious disease doctor from Chicago by the name of Dr. Howard Ricketts. And he came to western Montana. He actually started off working in Missoula and coming down into the Bitterroot Valley to collect samples and collect samples and specimens. Within a couple of years, he figured out that Rocky Mountain spotted fever was an infectious disease. It was transmitted to people by the bite of a tick, and wasn't transmitted between people, but it was spread by the bite of a tick. And he characterized that, and he was able to recapitulate that model using animal models. So he figured out what Rocky Mountain spotted fever was in just a couple of years. There was still no treatment or anything for it, but at least they knew what it was. And unfortunately, Dr. Ricketts never worked at anything called Rocky Mountain Laboratories, because he died in 1910 working on an outbreak of a disease called typhus in Mexico City. And he went down to study the typhus outbreak, and unfortunately he caught it when he was there, and he died at a really young age. I don't know exactly how young, in 1910 in Mexico. But the people that worked with him and then came to work with him went on to study Rocky Mountain spotted fever, and they started off in Missoula. Then they had a couple of little installations in a town called Florence and a town called Victor. And then in around 1922, Dr. Parker and Dr. Spencer worked in an abandoned schoolhouse on the west side of the Bitterroot River, which came to be called the Canyon Creek Schoolhouse, or the Schoolhouse Lab. And it was in that laboratory where Dr. Spencer and Parker came up with the first vaccine against Rocky Mountain spotted fever. There were no such things as antibiotics back in those days, but people had known about vaccines for quite a while. The first vaccine consisted of going out, collecting ticks, putting them in a mortar and pestle, grinding them up with phenol, which is kind of like an embalming solution, diluting it with buffer, spinning out the large parts of the ticks, and that was the vaccine. And that vaccine was developed in that schoolhouse lab, and it was tested, and it was used among the residents in the Bitterroot Valley for a really pretty long time. It was a pretty good vaccine. It wasn't 100% effective against preventing the infection, but if you got it after having the infection, usually your infection was a lot milder. So they worked in that schoolhouse lab until 1928. Then, in 1928, the first building on the site where we currently are in on the south end of Hamilton, Montana, was built. It was called Building 1, obviously. And it was originally built for the Montana University System Department of Entomology for the state, but it became very apparent after a short period of time that these tick-borne infectious diseases were not limited to western Montana, but they were national and international in scope. And so the facility reverted back to the United States Public Health Service. All of the previous labs until they moved to this site had been U.S. Public Health Service labs. And it wasn't actually until 1936 that it officially became called Rocky Mountain Laboratories.
Presently, the Rocky Mountain Laboratories continues the study of tick-borne infectious diseases and has an extraordinary significance in being a facility for biomedical research not only in Montana, but beyond. Over the decades, the spirit that fueled those early discoveries only grew stronger. Breakthroughs led to new questions, new challenges, and new opportunities. With each step forward, the laboratory expanded its mission, blending scientific curiosity with modern innovation and focusing on viruses that can cause severe illness across the Northern Hemisphere.
People living in Montana are probably well aware of many of the tick-borne infectious diseases. The ones that we presently have in Montana, which are spread by ticks, are number one, Rocky Mountain spotted fever, and that's a bacterial infection. The bacteria that cause that were named after Dr. Ricketts. They're called Rickettsia. The second one is a bacteria that causes a disease called Q fever, and it's caused by a bacteria. It's also spread by a tick, although it can be spread by other means. It's called Q fever because when they first knew it, the Q was a query because they didn't know what it was. That was discovered in Rocky Mountain Labs right around 1936. The third one is one that's called Colorado tick fever. That's a virus infection, and there's no vaccine or treatment for that. Let me go back to say that in terms of Q fever, there is a vaccine for that, which was developed at Rocky Mountain Labs, but it's not given anymore. It's a bacterial infection, like Rocky Mountain spotted fever is, and once antibiotics became available, the interest in vaccinating the general population against those agents sort of declined because the number of cases weren't all that many to merit vaccinating the entire population, unlike measles, which is highly infectious and contagious among people. So tularemia is also a bacterial infection, and it's treated with antibiotics. There are vaccines available, but they're not generally used in the United States. Colorado tick fever is a kind of a virus, and we have a fair amount of that here in western Montana, particularly in some of our canyons where people go rock climbing. There are ticks there, and people can catch it there. I have a good friend who caught it there. And with regards to Colorado tick fever, it's kind of interesting because in the late summer of 1805, when the Lewis and Clark expedition was making its way up the upper Missouri River, up what's now the Jefferson and the Beaver Head, Meriwether Lewis came down with an infection which didn't spread to the other members of his corps, And a lot of people suspect that what he had was Colorado tick fever back at that time. So we have Rocky Mountain spotted fever, Q fever, Colorado tick fever. There's another very serious infectious disease caused by another bacteria, and that infectious disease is called tularemia. Some people know it as rabbit fever. It's not usually a tick-borne infection, but it can be carried by ticks. So that's 4. Then the other thing that so those are the 4 major ones. But there's another one which is really kind of weird, which is called tick paralysis. This is very rare, but there have been cases of that in the state of Montana. In fact, a friend of mine that works at Marcus at Bitterroot Health, which is our hospital, had a patient with this some years ago. This is a disease where the tick is not infected with an infectious agent, but the tick secretes in its saliva a toxin, and that toxin leads to a paralysis, starting in the feet and going upwards, paralyzing the muscles. That's called an ascending paralysis. The way that that is spread, a female tick, one of our wood ticks, standard ticks that people are familiar with them when they go out hiking and everything like that. A female tick will embed and will engorge with blood, and typically after they've been on a person feeding for about 5 to 6 days, they'll develop, if the tick is secreting that toxin, that individual will develop that ascending paralysis. The treatment for that is bonehead simple. You just take the tick off, and then in a very short period of time, the paralysis goes away. The problem is, if you don't find the tick, the paralysis will persist. So those are the major tick-borne infectious illnesses that we have in the state of Montana that are documented to occur and known for certain to occur in the state of Montana.
Once the lab cracked the early mysteries of Rocky Mountain spotted fever, it didn't just sit back and call it a day. Not even close. Instead, Rocky Mountain Laboratories leaned in, taking on new microbes, new outbreaks, and new scientific puzzles. And the team of scientists truly love challenges. You could almost say the lab caught the research bug, because from that point on, its list of studies only grew longer and more fascinating. As science evolved, so did the laboratory's reach. New technologies, new expertise, and new questions propelled the laboratory into a future filled with possibilities. Today, their laboratory also has research groups that study other infectious illnesses like COVID-19, Tulmaria, Salmonella, Pyron diseases, and Lyme disease.
The bacteria that causes Lyme disease, which is called Borrelia burgdorferi, was identified by a scientist at Rocky Mountain Labs by the name of Willie Burgdorfer. Those ticks came from the East Coast, where Lyme disease had been discovered. But Dr. Burgdorfer, who was a real expert in insects and arthropods like ticks and lice and mosquitoes and things like that, he was sent some of those ticks, and he noticed that some of the ticks had a sort of a curlicue bacteria in them. And he said, that's a spirochete, back in around 1981, he and some of his colleagues, that's a spirochete. I bet that's the cause of this Lyme disease. Because the people who had identified Lyme disease back in the East Coast, they had looked for bacteria, they had looked for viruses, and they had looked for other infectious diseases. But the spirochetes, like Borrelia burgdorferi, they take a very, very special kind of broth to grow, and most people would not have used that. Now, there were other people here at Rocky Mountain Labs at the time working on other types of spirochetes. So what Dr. Burgdorfer and his colleagues did is they went down and they got some of that media, and they tried putting some of this material in it, and bang, these spirochetes grew. And then they did some tests to show with serum from patients who had Lyme disease on the East Coast to show that the bacteria reacted against that, that the antibodies from those patients reacted against the bacteria.
Rocky Mountain Laboratories research plays a leading role that could help keep Montana, the United States, and the world safer against a wide variety of infectious diseases. All this work continues, the mission built by the scientists who came before. A mission grounded in protecting communities, improving public health, and advancing science. Its findings influence treatment, prevention, and public health strategies around the globe, ensuring that the science developed in the Bitterroot Valley continues to save lives far beyond it.